In this example, Fr is the force exerted by right hand, that is shown here, this force. Fl is the force exerted by left hand, that is shown here, and W is the weight of the pole. Okay. So if we choose the origin or the pivot point at this point, okay, so let's say this point is A. Okay, so if we choose the origin at point A as shown in the figure, we can write total torque about the point A should be 0. So this is the total torque about the point A should be 0. In our case, we have three forces, so we can write torque due to force Fr, torque due to force weight, torque due to force Fl. That should be 0 at equilibrium. So this is true at equilibrium. At equilibrium. Right? So here clearly this is the torque due to force Fr so we have to find the torque due to its force. So let's see here. Say this is the pivot point or origin A. One force is through Fr. One force is Fr through the point A, right? So torque due to Fr will be, because we have the equation for torque is, the torque equation is tau equals R times F sine theta. For this case, Fr force passes through this point origin, so this will be 0 times Fr sine theta, that gives you 0. Okay, let's consider the torque about the point A, for the force weight, right? So be careful that here the distance between the left hand and the right hand, that distance they give us is 0.7 meter. And according to question, if you look at here, the distance between center of gravity of the rod and the left hand, they give us 0.55 meter. That means this distance here, distance between force due to the right hand and the center of gravity of the weight, that distance will be 0.7 minus 0.55, which equals 0.15 meter. Okay, so that is the required distances. So here we can write torque due to weight, which equals weight times this distance, which is 0.15 times sine 90 degree. because this will produce the clockwise torque, that gives us minus weight. Weight is from previous slide, weight is 47.04 times 0.15 times 1. Okay, so that will give us 7.06 Newton meter, minus, because of this torque, this torque will produce rotation is the clockwise torque. Okay, so anyway, so this is for torque due to weight. This is the torque due to the force exerted by left hand. Talk about the left hand, we can write this figure as like this. This is the pivot point A, right? Our force due to left hand is FL. The distance between left hand and the right hand is 0.7. So we can write torque due to the left force FL will be tau L equals FL times 0.7 times sine 90 degree. You can see the angle here. That gives us FL times 0.7. So this will be the counterclockwise torque. Counterclockwise. Now we can use the condition of total torque is equal to 0 at equilibrium. So we can write tau R plus tau W plus tau L should be 0. So if you plug the numbers 0, negative 7.06 plus FL 0.7 times 0. So we can do a little bit algebra here, right? That gives us FL equals 10.1 Newton. Okay. Next is we can use the other equilibrium condition. Total force along y-axis is 0 because here all the forces are along y-axis. So this is the condition for equilibrium, condition for static equilibrium. Okay, so we can see here, if we consider up positive along y-axis, down negative along y-axis, we can write FR plus FL plus and W minus, that equals 0. Okay, so we don't know FR, but we do know FL. This is 10.1, and the weight will be, we figure out already, it is 47.04. That gives us FR equals 36.94 Newton. So here we use both the condition of equilibrium. Okay, this is also the condition for equilibrium, condition for static equilibrium. Okay, if you understand the concept learned so far, you can practice 2, which is a very similar problem. You can practice 3. You have to use the concept of torque concept. If you remember the equation, tau equals R F sine theta. You need to use this equation for each force. Okay. Third one, the practice problem 4th is also based on similar concept, but here there are 3 forces. One is FH. This is the force exerted by hinge, right? Ft is the force exerted by cable, that is here, and weight of the beam. Be careful that it's not center of gravity is not at the center. It is very close to the, say, if you choose this as a pivot point, right? So as a hint, my recommendation is use total torque is equal to 0. So here we have 3 forces: torque due to weight, plus torque due to hinge, plus torque due to T is equal to 0 at equilibrium. So this is the torque is all about pivot point as shown in the picture. Okay. So if you use this condition and solve as before, you get FH. You get FH. Now you need to find force due to hinge. So use total force along x-axis is equal to 0. So you have to find what is the component of FH along x-axis. Find the component of W along x-axis plus component of F T along x-axis is equal to 0. This is the x component. So this is clearly 0 because no x component or weight, right? This will be, if you use SOHCAHTOA, that will be FT cosine 40 degree. But you know that this is minus. If I assume up along y-axis, up positive, down negative, along x-axis, I assume left as negative and right as positive, okay? Similarly, this will be, you can replace this by FH cosine theta. You have to do similar step for the y-axis. Total force along y-axis must be 0. In this case, force FH component y, weight component y, plus force Ft component y should be 0. So clearly here this will be FH sine theta. This is only, the weight has only the component y, so that will be replaced by just the weight. So you can find, they give you the mass. Okay, they give you the mass. So one thing I forgot here to tell you that one car is here. So car is sitting at the center here. So you need to add one more force, torque due to car. Okay, that also exerts the force. So we have basically not 1, 2, 3 force, we have 4 force. So This is the weight of car. We need also that. So similarly, you have to add one more. So force of car along x-axis, because the weight will be vertically down, so this also will be 0 in this case. So here we have to add force Fc component y. This is the vertically down, so you have to add 920 times g, which is 9.8, right? Then plus wy, you can find the weight of the bridge from here. So this W will be 2550 times 9.8. This will be negative. And the component Y of Ft will be Ft sine theta equals 0. So you already figure out Ft and the Fh. You can find that all of these, right? So from here, basically, we are finding the torque due to the torque due to the applied force. So it is basically Ft. So you'll find Ft here. So this is the hint. Based on that, you can answer all the questions